everyone. Today we'll be talking about separation techniques. Yes, the last time we talked about compounds and mixtures. So for our mixtures, we use some techniques to actually separate them. Depends on the solubility, on the nature of some of those substances and all that. So I'm going to be discussing a few and probably the industrial application. So separation techniques are the method or the techniques in which mixtures are being separated. Then there are some mixtures that you recover the two constituents. You might recover everything, while some of the constituent might be lost along the way. So we have different ones. Okay, so let me just name, the first one, you can have the filtration, you can have evaporation, you can have distillation, or you can also have fractional distillation. You can have centrifugation. You can have sieving. You can have decantation. You can have magnetization. You can have, which one do we have there again? You can have, evaporation is there already. Sublimation. You can have precipitation. You can have chromatography. You can have crystallization. And I think fluctuation. Okay. So let's just see how far we can go today by taking them one after the other. Okay, filtration is a beautiful one whereby you use the filter paper or you use the filter bed. In the purification of water, the filter bed is being used. Now, filtration is all about you separating solid from liquid. Yes. Especially, let me just make use of the water purification as an example, whereby maybe you still have some particles, some fine particles. You have to filter it. The water will pass through, then the solid will now stay on your filter paper. At times in the lab, whereby we have some insoluble salts, yes, that are being mixed with water, we'll use the filter paper. We'll put it on inside a funnel, then you put the funnel inside maybe your test tube so that the water can drain out. Or maybe when you have two, maybe one is soluble, the other one is insoluble. So that one that is soluble in water will come out through the filter paper with the water, while the other one that is insoluble will remain on the filter paper. So the one that comes out as a liquid is what we call the filtrate, while the one that is on the filter paper is what we call the residue. So we use them in purification of water. That's, I can say, the industrial application. Okay, another one that we have is evaporation. We all cook in our various homes. Evaporation is another beautiful one. Most times the solvent, which is the water, is being sacrificed. For example, if I have my salt and water and I want to separate it, I'll put it on fire and allow the water to evaporate. So the water in that case is being sacrificed. I'm not going to get back my water. So it's being used in the production of our salt and all that. Okay, distillation is being used in distilleries and breweries, whereby you have the whatever that is being distillated is being collected and channeled as the water vapor, like that. Then the fractional distillation is a very beautiful one. Is being used in the refinery to separate our crude oil. You know, in your crude oil you have the petrol, the kerosene, the diesel, you have even bitumen, you have the heavy oils and all that. So your fractional distillation is being used according to their boiling point. You know water boils at 100, isn't it? Now when water boils at 100, it starts to evaporate, then the vapor and all that. So that is exactly what happens here when it starts to boil and it gets to their boiling point. Yes, it goes up and it will be passed through the fractionating column, and like that they keep going as they get to their boiling point. Okay, centrifugation. How many of us have gone to the hospital before and your blood sample is being collected? Have you ever wondered what they do with those blood sample? Now what they do most times, they will collect your blood sample and spin it. Do you know that your blood is a mixture? In your blood, you have the white blood cell, the red blood cell, the platelet, and the plasma. Yes. They will spin it through the centrifuge. When they spin it, it's being separated, and the lab people, they are able to conduct the test. So centrifugation, the application is majorly in the hospital through the use of the centrifuge. Then another one is sieving. Yes, I think everybody is used to this one at home. For your sieving, you can have solid substances of different sizes. Yes, for instance, that if I have my garri and it's mixed with my beans in the house, what will I do? I'll just carry my sieve that is a bit bigger, you understand me, but of course the one that the beans cannot pass through. So if my beans and garri are together, I'll just put my sieve, shake it so that the garri, which is of the smaller particle, can come out. So for sieving, we use it even in garri industry. Okay, now let's move decantation. Decantation is being used for when you have your solid and your liquid, especially when you have a solid that is being suspended in the liquid. After some time, it will settle down. Then when it settles down, then it will now, your water, it will be easy for your water to be decanted. So when that one is being decanted, the remaining water in the mixture can be evaporated through evaporation. Okay, I think I didn't write separatory funnel. Yes, separatory funnel. Okay, separating funnel. Okay, the next one is our magnetization, especially when you have iron fillings in some substances. You know, your iron can be attracted by a magnet. So when you have that, you can just use the magnet to pick it up. Okay, sublimation. Sublimation is when you have a solid substances converting directly to a gaseous substances. So for instance, maybe you have a mixture, you have iodine, or you have phenolphthalein or ammonium chloride there. Those are substances that can actually sublime. So what comes to your mind? Okay, you look at it, oh, these substances can actually sublime. What you do is that you put them on fire, immediately they will sublime, and you get the other one. Okay, precipitation. We use this in the lab, whereby we have some salt, and when they react together, a particular one can be precipitated out for you to get that. Chromatography most times is being used in color separation, maybe like the green pigment in plants, you can get that as well. Yes, crystallization is being used, okay, to get some solid out of some saturated solution. You get the crystals out in solid substances. Then you have the separatory funnel. This one is being used to separate what we call the immiscible liquid. They cannot be mixed together. Yes, like maybe your oil and your water, you have something like this, and maybe there is a tap. You understand me? It can be oil or water, it can be petrol or water, like that. So the one with the higher density will be down, while the one with the lower one will be up. So most times you just open the tap and the water just comes out gently till when you have till when you get to the thin line. Of course, this is not an accurate way of separation, because most times you don't some of the mixture can mix at the end of the day, but you can still find a way to separate them. So those are the separation techniques that we have. So you are going to use your fruitation as assignment. At least I've explained close to about 13, so you can use the others. And please learn the diagrams also. Yes, a diagram can just be given to you and you can be asked to explain that what is this diagram used for. They can draw for evaporation, they can draw for fractional distillation, they can draw for distillation, they can draw for filtration of evaporation, or even sieving, yes, or even decantation. So please get used to some of the diagrams of this separation technique. So when next we move to other aspects of chemistry. Tell your friends, please subscribe on the page Chem Classroom with Aunty Taiwo. Click on the notification button, okay, so that you get notified. Then please tell your friends that something is happening on YouTube. They should subscribe, view, like, and share. All right, see you some other time. Thank you.